I guess another recording here. There was a question I saw pop up on your Alex that I did record in the long video, but I did not actually do with you guys in class. So here, I'll do it here. Probably just take a few minutes. So something like this. Let's say you're in a boat in a river, or there's a variation of this where you're in a plane in the air that's blowing, so you got some wind, right? And either plane with wind or boat with, in a river with a current. Uh, let's say a one-way distance, it takes a certain amount of time. And then when you go back the other way, it takes a different amount of time. Because in this case, if you're flowing with the current, you're getting a boost from the current. So maybe it takes a small amount of time. But if you go upstream, aren't you fighting the current? So it's going to take more time to return back to your original location. Okay. And maybe you're given one of these values. Like, because what if the speed of the current is equal to 5 miles per hour? Right. So all my distances are in miles, my times are in hours. Okay. And the question is, what's the speed of the boat? And that's what you got to solve. Okay. So that's your goal, is to find what's the speed of the boat so that going 120 miles downstream takes 2 hours, and the same 120 miles, but upstream takes 2.4 hours. You guys got the difference? Right?
Yes, sir.
And so you can start with something basically like distance equals speed times time. Now I'm going to replace this with distance could be x, speed could be something to do with v, and time I'm just going to call t. Okay? But the speed is really either a difference or a sum of speeds. Now, when you're going downstream, the boat's getting a boost from the current, so I'm going to add the speeds. And when the boat's going upstream, it's fighting current, so I'm going to subtract the speed, the relative velocity speeds, right? V for velocity, so I'm pulling that from physics. Okay. No, it's really like the boat relative to water and the water relative to the shore. So what's the boat doing relative to the shore? Okay. So I'm going to set up this equation. So the distance downstream could be 120, that's miles. Okay, is equal to, now the speed could be speed of the boat, which we're solving for, plus the speed of the current, which I know is 5 miles per hour. Right? And it takes some amount of time. Actually, I know how much time. 2 hours. There's different variations on this, right? But I'll start with this like this framework, right? So this setup. Right? Now, go back the other way. It's still 120 miles back the other way. Okay? But now it's the speed of the boat minus the speed of the current, which again, we know the value of miles per hour. Okay. And this takes more time.
Is either the water there or the fire?
So be like this. Okay. So this right here is your system of equations. Right. You have two independent equations. And well, okay, we could use. Wait a minute. Did I? You know what? I think I gave you guys too much information here. Okay, guys. Usually there are two unknowns. Right. Let me make sure I get this right. I think you got. Yeah, 60.
I got
50.
Why'd you throw that
Times
out?
2.4.
Okay.
Okay, guys. Let me go back and amend something. Let's make believe I did not give you one more number. Okay. Guys, what if I did not give you the distance, for example? What if you don't know the distance? You could still solve this. Normally, if you have two independent equations and two unknowns that's solvable, that's what I meant to do. So let's make believe you actually don't know the distance either, which is okay because the fact that you know it's the same distance is all you need, because that means that these equations would be equal to each other, and then you can still solve it. So I can go on. I can say this v plus 5, v boat plus 5, let's drop the units, right, times 2 hours equals v boat minus 5 miles per hour times 2.4, and that would be hours, something like that. Right. Okay. So now, now this looks a lot more like traditional algebra. Okay. And so again, I think this comes from the last lesson, so 9.6, where you had to take a story and figure out how to turn this into the model with equations, come up with the system. Okay. And once you can do that, then you can finish the algebra. So I'm going to distribute here 2 times speed of boat plus 10 equals 2.4 speed of the boat minus, what is 2.4 by 5 is 12. Yeah, that's right. Okay. All right, so let's get the VBs on one side. So minus 2VB, minus 2VB, and then add 12, add 12. Okay. So I'm getting 22 equals 0.4 speed of the boat. Okay. Divide both sides by 0.4. Okay. 22 on 0.4. All right, so I'm looking at the speed of the boat is 55. Okay. Now the unit would have been miles per hour if I kept my units, miles per hour. Okay. And then if you like, you can also go back to the original statement. All right. Now, again, I accidentally gave you guys too much information to start with, but let me show you guys that this would still work. So if you do here, starting from the answer here, I know 55 miles an hour, okay, plus the river current. Okay. Now the speeds are adding relative to the shore times 2 hours. That brings you to 120-mile distance downstream. Okay. And then go back the other way. If you do the speed of the boat that we found right here, minus the speed of the current, because you're fighting the current, times the longer time, okay, it still works out to 120 miles. So it still works. Okay. But there you go. That's how you set that up and solve that.